Question 1 from the 2025 National 5 Physics exam from the SQA, taken from the first paper. Which row in the table shows both the quantities classified correctly? Well, let's go down the column and let's look at each of these quantities one at a time. Weight is really a vector because it belongs to the force family, so it shouldn't be in the scalar column, so that's wrong. Force is a vector, so that is correct. Distance is a scalar quantity, so that's correct. And velocity is a vector quantity, so that's correct. So it looks like B is the correct response, but let's continue. Mass is a scalar and distance is a scalar as well, so that's in the wrong column. Force is a vector, which is in the wrong column, so we cross that out. And mass is also a scalar, which is in the wrong column, a vector column here. Velocity is a vector, so that's in the wrong column, and time is a scalar, so that's in the wrong column. So we have the correct answer is response B. Question 2. The graph shows how the velocity v of an object varies with time, and you're showing the graph there. And our job is to find the displacement of the object at 2.0 seconds. Now, if we look at the graph, we can see that the velocity is decreasing. From here, it's going from 6 meters per second. The velocity is decreasing until it gets to a 0. And then what happens is the velocity goes negative. Now, what that means is that it's going in the opposite direction. So from this part of the graph, the object is travelling to the right, say, and in this part of the graph here, the object is travelling to the left. So when we come to work out displacement, we have to work out the area of the graph. And the first one is quite simple. We just work out the area of that triangle there. But the second little area here, we have to subtract that because that's in the negative direction. It's going in the other direction. Therefore, we have to subtract that little area to get our final displacement. So let's go ahead then. We can see the first triangle. It's got a height 6 and it's got a length of 1.5. So that's that triangle there. And if we work out the area of that triangle, we get the following. The area is equal to 1/2 times the base, which is 1.5, times the height, which is 6. And the area of that triangle comes out to be 4.5. So our first displacement is 4.5 meters towards the right. Now let's look at the triangle which is below the line here, and remember we work out the area of that and subtract it from the green triangle to get the full displacement. So there's that little triangle here. It is actually 0.5 meters in length because we're going from 1.5 to 2. So that length in there is actually 0.5 as written down here. The height of the small triangle is 2, but we're going down to -2. So we've got an area to find of this small triangle. We work it out. We get an area equal to 1/2 the base as usual. So it's 1/2 times 0.5 times 2, and therefore we get an area is going to equal to, in this case, it's going to be 0.5 meters. But remember, it's going in the opposite direction. It's going in that direction there. So therefore, the total displacement of that object is going to be to the right. Is going to be a value of 4.5. So we write down 4.5 meters. And then this little red part here, which is below the axis, we have to subtract that 0.5 away. So the total displacement is going to be 4.0 meters. And the response for that is going to be A. Question 3. A car is travelling along a straight level road. The car slows down at a constant rate of 2.0 meters per second every second for a time of 8 seconds. The final speed of the car is 5 meters per second, and we've got to calculate the initial speed of the car. Well, we go and look at our equations, and we know that the final speed of any object which is accelerating from an initial velocity u, we just add on the acceleration times the time. So that's our basic equation there. Now we know what the final velocity is. It's going to be 5 meters per second. So we'll put in 5 there. And we're asked to find what the initial velocity is, which is u. Plus the acceleration times the time. I'll put that in brackets. The acceleration is, the car is slowing down at a constant rate of 2 meters per second every second, which means acceleration is -2. And multiply that by the time it was decelerating for, 8 seconds, and we've got a simple little equation. 5 is going to equal to u, and this is going to give you -16, like that. So therefore, to find out what u is just a simple case of saying 5, take the 16 over, and we get 5 plus 16, and the initial speed of the car is going to be 21 meters per second. 21 meters per second, and the response for that one is going to be D. Question 4. A cup rests on a table that rests on the earth. The cup exerts a downward force on the table, and which of the following is the reaction to this force? Well, let's take a look at the diagram, and it's all summed up in the diagram there. The cup exerts a downward force on the table, and the reaction force to that is that the table exerts an equal force upwards on the cup. So we're looking for the force of the table on the cup, which is going to be an equal and opposite force, and that's going to give us the following response. The response is going to be A for this one. Question 5. A crate of mass 180 kilograms is lifted through a height of 3.0 meters in 2.5 seconds. The minimum work done in lifting the crate through this height is, and we're given the following responses. Let's see what's happening in the diagram. We have the floor, and we have the crate here, and we have to lift this crate up to a height of 3 meters. So what we can do here is work out what the minimum work done is, and the work done is going to be given by the formula. Work done EW is going to equal to the force times the distance. That's the force you apply to the object to move it through that distance. In this case, it's the height. So what is the force required to lift a 180 kilogram mass? Well, that's usually going to be its weight, and the weight is going to be the minimum force you need to lift this up with, and that's why it's asking for the minimum work. So our equation changes to the following. EW equals the force required to do it, the minimum force, is just really equal to the weight, which is mg, and distance d is going to be the height h. Does that ring a bell? Of course it does. It is EP, the potential energy, equals mgh. Because if we do work in lifting this 180 kilogram tray up the way, then we are transferring energy, work done, and it goes into potential energy. So let's work out the work done in lifting this up. The mass is going to be 180. G for Earth is going to be 9.8, and the height for lifting up is 3 meters. So we get the following answer. We plug that into a calculator. We get 5292 joules of energy. Now we have to put that into significant figures. So if we put it into two significant figures, as we have in the calculation, two significant figures means we go for here 1 to 2, and therefore it's going to be equal to, this one rounds up, and we get 5300 joules. So our answer to two significant figures is going to be 5300 joules, and that's going to give us a response of E.